So today's problem is the longest palindromic subsequence. So we have a given a string s, find the longest palindromic subsequence. Subsequence is basically not the subarray. So basically we can create a new string by deleting any character. So for example, right, okay. So if I have a string and I have to check whether this is palindrome or not, right? So we can just simply go ahead and start from the start and the end, and if they are same you keep on moving forward towards the center, and if they reach at the center, that means a palindrome. Now for the subsequence part, so I have the option to either delete this character or delete this character or delete this or delete in the first pass. Suppose it's the first pass, so I can delete any one of the character or one by one all of them, and then I can check whether they are actually valid palindromes. So for example, in my first string, so you have say 1 2 3 4 5 6, so you check whether the string from 1 to 6 is palindrome or not. If it is, then it's the longest palindrome in the sequence, so you return that. Otherwise what we can do is that I can start from 1 towards 6 and decide on every character to delete. So for example, like first sequence could be 1 3 4 5 6, then 1 now we'll delete 2 3, so 2 4 5 6, then you delete third one, so no, not delete 4, so it is 1 2 3 5 and 6, and then we are going to repeat the same process here, check whether this is palindrome or not. If not, then you try all the substrings in that. So this is definitely going to solve a problem, but at the time complexity for this is going to be pretty high. But during the interview setting, right, it's always better to check with your interviewer to see if it makes sense to code this problem or not, because sometimes interviewers are totally okay with solving the uh, naive way of solving the problem. So let's code this and see if we can get at least like one or two test cases working. So now check if the string is null or empty. Okay, I don't like s, make it str. Return 0, and then if my str dot length is less than or equal to 1, I just return str, basically it's a 1, right? And then I'm going to check if my if is valid palindrome str, and if it is, then you just return the length of this string, because it's going to be the maximum length of the possible palindrome. Now as we discussed, if we'll integer result is equal to 0, then for let's traverse a string, right, and the left portion of the string could be, I'm just deleting the if character, right? So suppose I am deleting g here, so the left part is len and right part is th, so which is str dot substring starting from 0 and length is I, and the right portion is str dot substring substring of I starting from I plus 1 till the end, and then we get call this function recursively, and we pass on the left plus right and get the length possible from this substring, and then we say result is equal to math dot max len comma result, and you say return result, right? Okay, we have to implement this function, so let's go ahead and do that. Should not take much longer. Integer start is equal to 0, end is equal to str dot length minus 1, and while s is less than or equal to e, and if str of s is not equal to str of e, because it will just help me to terminate loop early, return false. And if they are same, so we'll increment the s and decrement the e, and if we reach till the end, that means it's a palindrome, return true. I'm sure it's going to be TLE, so let's submit this. Okay, so it failed pretty early, 10. So the thing here is that the time complexity for here is going to be, let's just take a look. So we are going for every function with the length n, and I'm trying to delete one letter from each one of them. So that means if I started with n characters and I deleted 1, so I have n minus 1 left, and I'm going to call the function on n minus 1. So the polynomial the complexity for this would be n into then n minus 1 into n minus 2 dot dot dot. So it is like factorial n, and if we add the complexity for checking if it's palindrome, so it's n times factorial n. That's why it is failing pretty early, like 10 to 12 characters only. Okay, so let's see how we can do better. Another better approach could be that, so for example, if I have a string, right, and it's a polynomial that we're again going to be start and end. So one thing is that, like, suppose you have to check, so how about that if you check this string, this character, and you check this character, right? So if they are same, that means that now the maximum, the longest palindrome sequence will be uh, whatever is present here, get the maximum longest palindrome subsequence from this string, and since they are same, so it will be 2. So that means that if they are same, the length is going to 2 plus the length that comes from this area, right? Otherwise, if they are not same, so we can have the option, either we will take this substring, or we can take the substring. So let's define it mathematically. So let's say that this is position I and this is position j. That means that if str of I is equal to str of j, that means that this is going to be your palindrome. So that means that the maximum palindrome will be 2 plus, the name of the function is longest palindrome subsequence str comma I plus 1 to j minus 1. Otherwise, what we're going to do is that take this string, so which is going to be lps of str comma, that is I comma j minus 1, and starting from this position, that is lps str I plus 1 comma j, and we will return the maximum of these two. So now let's code it. So the changes that we have to make is that I am going to add a private function that's the integer lcp string str integer start index integer end index, and if my si is equal to ei, that means it's a one character only. That means that it's a palindrome of length 1. And if by chance we reached a position where si is greater than ei, that means it is actually not possible, so we will just return 0, right? Otherwise, the first condition we have is if str of si is equal to str of ei, str of si is equal to ai, then return 2 plus lcp str si plus 1 and ei minus 1, else return math dot max lcp str comma. So we are going to start from si to ei minus 1 and cp str comma si plus 1 comma ei, right? That's it, lcp. Now we will call it from here, so we don't need these things. Just say return, we also don't need this, return lcp str comma 0 comma str dot length minus 1, right? Oh, we don't need this also, let's just keep it, otherwise. Okay, so we are going to hit TLE, but should be a little bit better than the previous approach. Okay, so TLE, but we reached till 61. Okay, sounds good. And the length of the characters was much longer than previous one. Now if I take a look at this function, is we have two variables here, si and ei, and in this, if you look at this, we do have some overlap between si and ai, so it is possible that I am solving the same problem again and again. That's where the dynamic programming and the memoization comes in. So a rule of thumb is that I have two variables in this equation, so starting and end index, and we have to store the result for these. So let's create a memoization array, new integer, and the size for this would be length of the string, right? So this is n comma n, and I'm going to pass it memo in this function, and this was going to passed here inside this function, and memo and memo. Okay, now so we got this function memo here. Now we're going to check if, so by default this memo is all elements of this two-dimensional matrix is assigned with value of 0, and by default every character of the string have at least longest palindrome sequence of length 1. So that means that if I can check if my memo of si comma ei is not equal to 0, then we are going to return the memo of si and ei. Okay, and then if it is not, we are returning result from here. So instead of returning, I'm just going to store it in the two-dimensional matrix, my memoization, and at the end I'm going to just say return memo of si comma ei. That should be good enough. Give me a semicolon. Okay, sounds good. And looks working. Sounds great. That's for today's. See you tomorrow. Thank you.